Binary ionic compounds are the first ones that we will start naming. Binary ionic compounds, called binary for this reason right here, is that they have two parts in the name. Meaning that you have the cation that comes first, and then the anion that comes next. There's no parentheses, there's nothing in between. Now, in order for us to accomplish this, we have to use the common ion sheet. This is a sheet that contains all of the positive and negative ions, the cations and the anions. And we will use it to name not only compounds, name them, but also provide the formulas when the names are given. Now, this is provided, and let us actually go there. So your common ion sheet has two sides to it. It has the cations, this is the positive, and they are shown, or they are grouped based on their charges. So you have the +1, the +2, and the +3. So for example, lithium has a +1 charge and it's called lithium. Ammonium is what we call a polyatomic. We're going to get to it in a second. Has NH4 plus and it's called ammonium. Now you have, of course, another side, and that side contains the anions. So they're also grouped by their negative charge. So they have a -1, -2, and -3. And of course, they contain monatomic, meaning one atom ions. And of course, they have polyatomics. So become really, really situated and become familiar with this table because we will use it. So let's go back to the cation, as I said, is always named first and the anion is second. A monatomic means one atom ion. Takes the name from the parent element, so you don't change anything to its name. You just call it, for example, it's sodium. You just call it sodium. But the anion, if it's monatomic, you have to end with I. Now, all of this is taken care of on that sheet. So we're just going to do problems. And before we begin, this is also another example where you have to practice enough of this. So make sure you do enough of these problems to develop a pattern. And generally, there's no problem with this topic because it's very systematic. So when you have something like this, the first question you should ask yourself is, do I have a metal and do I have a non-metal? Because if you have a cation and an anion, that 99% of the time translates into a metal and a non-metal. So if you have a metal and non-metal, then it must be an ionic compound. Now, how did we find that out? Well, if you recall from one of the last few videos, is we talked about the periodic table. And if we look at the periodic table, we can determine what's a metal and what's a non-metal. So a non-metal is right here, and the metal is anything to the left of this staircase line. So I had calcium in the last example. Here it is. So that's a metal. And I had Cl. Now I know it's covered right here, but Cl is right there. So it's, again, one of the non-metals. So therefore, you use this system. It's critical that you do that because the molecular compounds, that's the other type, are named differently. So let's begin. We have K and we have Cl. To name this, all you have to do is look up the name of each. So if I go to my table right here, I'll see that I have K in the first column right here. Here it is. And it has a plus charge, and it's called potassium. And Cl would be right here. And that's called chloride Cl minus. So it's a very simple example. Now, before I put the name, so again, here's potassium chloride. Which is medicine that's needed for the heart. If you ever worked in the hospital, you'll know that heart patients get that medication. It's called potassium chloride. Now, notice that the charge is canceled out. I had a positive 1, canceled out the negative 1, so that's a 0. So therefore, I had KCl. So let's go to the next one. The next one is I have Mg and I have F. I'm going to go look up Mg. Now for the basic ones, you probably should know them. What is Mg? What is some of these simple ones? So you will have Mg right here. That's called magnesium. And then on the other side, we had an F. So that's right here. F minus or F is called a fluoride. So the name of this is magnesium fluoride. Now, if you're wondering what happened, why do I have an F2? Well, if magnesium was a +2 from that chart and F was a -1, you had to balance the charge. And there's a quick way of doing it, but sometimes you actually have to do it a longer way. But the quick way of doing it is you simply just cross the charges. So there's a -1 there. And there's a +2. So you take the numbers, only the numbers. And you put it after the F, fluorine, and you take the 1 and you put that after the magnesium. So it becomes MgF2. So let us now go to the other way around. So we have lithium oxide. Now let's go and find lithium and oxide. So lithium is all the way at the top. It's a +1. Lithium. And oxide is right here, O -2. So I have Li plus O -2. Now, once again, if the charges are different, like 2 to 1, 1 to 3, etc., then you can cross them. But let's actually explain what's the point of crossing them. So again, this is a +1, and that's a -2. So they can't cancel out. So the only thing you can do is you can actually add another lithium with a plus 1. So plus 1, 1 plus 1 is 2. So this side will be a 2. Therefore, it can cancel out with a minus 2 on O. So that becomes Li2O. Here's the quick method. Cross them. So it becomes Li2O. Now, of course, there's a 1 after it, but we don't show it. It's kind of like saying in math 1x. You don't say 1x, you just say x. So again, that's the whole idea. Let's go to the next one. We have aluminum nitride. So we go and find aluminum. Aluminum is right here. So it's Al plus 3. And nitride, make sure you look up the number correctly. Do not disregard the importance of this. Nitride is N minus 3. So be careful. It's an ide, nitride. Ends with an ide. You can sometimes confuse it with a nitrite, where we're going next with the polyatomics. So nitride is N minus 3. Oops. So the charges are equal. So they cancel out. And you're left with AlN as your formula. Now, let's talk about the ones with polyatomics, because these are very critical. Now, a polyatomic ion here is defined as an ion consisting of 2 or more atoms chemically bonded together and carry a net electrical charge. So you're no longer dealing with atoms that are individual atoms with their charges. The cations, yes, remain the same, but for some of the anions, they can be multiple atoms chemically bonded with an overall charge. So let's talk and let's actually look at this. You have permanganate, for example, is MnO4. That's manganese and 4 oxygens bonded together with a -1 charge. You have nitrite, NO2 with a -1, and nitrate, NO3 with a negative charge on the top. That's a -1. So look at it here. Basically, this is what's happening structurally. You have nitrate, an oxygen, 3 oxygens bonded to the nitrogen with a -1 charge. And of course, in nitrite, you have 2 oxygens bonded to a nitrogen with a -1 charge. So before we begin, this is how you would read it. So if I say nitrate, my business is only here with a charge on the top. So this does not mean NO-3. This is not the same. This indicates I have 3 oxygens, 1, 2, 3, with overall a -1. Imagine this was, just one atom, but now it's actually 3 atoms with a -1 charge. So be aware of that. So pay attention to the charge at the top. That's it. So let's look at an example. We have lithium. Now we did lithium before. It was an Li plus. And we have nitrate here, although we can look it up from the sheet, but since it's right here, we'll just borrow it from here, NO3 minus. So once again, you are to pay attention to the charges at the top in order to cancel them out or switch them. So obviously this is a +1, that's a -1. They cancel out. And now your formula will be LiNO3. So here's my metal, and then this portion is the non-metal. It does not change anything about the principle. It's still charges canceling each other out. So let's look at another one. We have sodium phosphate. So let's go find sodium and phosphate. So sodium is Na plus right here. Let me erase the other ones. And let's look up phosphate. Phosphate, phosphate, phosphate. If you can familiarize yourself with this, here is phosphate. It's PO4, so that's phosphorus and 4 oxygen atoms with an overall -3 charge. Okay, so I'm going to put the one when they're different here. So obviously, the charges do not cancel out. You have a +1, you have a -3. So what do I do? Well, you cross them, you cross the charges. So you take that 1, you put it after the 4, but it's not going to be 4e1, it's just going to be a 1. There's nothing, in a sense. And here you have a 3, you put that after the sodium. So it's going to look like this. Now, the other method, which I tend to, because I am just love to watch things, see things visually, obviously, rather than just, is if you see that this is a -3 and this is a +1, it's not enough. So here's another way of doing it is you say, okay, I need 2 more sodiums so they can actually equal -3. So 1 + 1 + 1 is +3. So this explains the 3 right here. You have 3 sodium atoms and 1 phosphate ion. Let's go to the next page. We have magnesium sulfate. Magnesium sulfate. So we did magnesium before. You can look it up. You can pause and look it up. It's going to be a +2. But we'll look up sulfate together. So if we go and find sulfate, it's right here. Once again, be careful which one you choose. This is sulfate. The one below that is sulfide. Different. So sulfate is SO4 -2. So you ask yourself, do the charges cancel out because they're equal? Then the answer is yes. We have a +2, we have a -2. That gives you a 0, so they cancel out. So your final answer is just MgSO4. So now, what do we do with if you have more than one polyatomic ion? So let's look up calcium and hydroxide. So calcium is right here. It's Ca +2. And hydroxide is on the other side. It's right here. OH-. Now, a question for you. You can pause and think about it. Is hydroxide a polyatomic ion? So you can pause and think about it. Yes, it is polyatomic because in OH minus I have oxygen and I have hydrogen. So yes, it's a polyatomic. So what do I do? You might say, okay, what do you do with this? Well, again, if the charges are different, you cross them. So your final answer should be Ca parentheses OH2 close the parentheses OH close the parentheses 2. Why? So you might have thought it should have been CaOH2. So this is incorrect. The reason why this is incorrect is because you're claiming here that you have one calcium, one oxygen, and two hydrogens. But remember, our OH minus, okay, all of it as a whole has a -1 charge. So you have to, so you need two OH minus molecules or ions. And that explains why it has to be CaOH2. So again, it is this that gives you this, not this. So again, this is where you need parentheses. And if the polyatomic is more than one, if you have more than one polyatomic ion, you have to use parentheses. That's why I like this method. It's just visual. It's there. I don't need to recall too much information for me to understand it. So next one is we have Mg. So that's magnesium. And we did the SO4 2 minus. That was sulfate. So that's basically the opposite of what he did at the top. Here's another one. You have barium. That's Ba. So, and we did OH. OH, when we did it up top here, it was a -1. So let's go find barium. In fact, you can actually get the charge if you think about it. If this is -1, you can get the charge of barium. If you think about it, it would be +2, but let's look at it from here. Here's barium, +2. So once again, 1 is not enough. That's why it was Ba parentheses, open parentheses, OH, close parentheses, 2, because you have 2 hydroxide ions. So that's called barium hydroxide. So do plenty of these. Pay attention to the polyatomics, and you will definitely understand it more clear.